that affect the demand, the magnitude, or we try to quantify the change in demand due to factors that determine the demand or factors that affect the demand, right? And then, so in the first day, we looked at both entities in the market, the demand, the consumer decision making, and also suppliers in terms of how suppliers make decisions. Or basically, we looked at the supply and demand when we discussed the demand theory and the supply theory briefly, and then we talked about the equilibrium of the market, right? We saw that the demand force and the supply force will, in an ideal market, without any other external force, will decide the price of a good or a service in the market, and that will determine the price and quantities sold and bought in the market, right? So today we will move on to theory of firm, but yeah, we also discussed utility and demand theory. So like I said, in the first 2 days, last week and this week, we will look at the theories and in principles of economics. And next week, we will look at some applications in economics, especially in the food and agriculture industry. And also, because you have a test at the end of the third week, we will look at some model questions that you could expect for the exam. Right? Okay, so this is where we stopped. Right, so we talked about the demand curve, the supply curve, and the equilibrium. So P star and Q star are the equilibrium prices and quantities. So these are the P star is the price that the consumers are willing to purchase, and also the suppliers are willing to sell in the market for any good. And Q star is again the quantity that both are happy to, which is sold and bought in the market. Right? So if they are, we discussed what would happen to quantity demanded and supplied if the prices change, prices increase or decrease. Right? So we can apply this theory to sort of illustrate or to explain any economic phenomenon in the economy around us. For example, how would a subsidy work? How would a tax work? How would quota works, for example, or price control, price ceiling or floor price, farm gate prices, change in prices, how that would affect the economy. So if you really want to look at how these economic impacts, or rather, let's say price control or tax or a subsidy, how that affects the entire economy. So a policymaker would want to sort of have a quantitative figure, right? How many rupees or how many dollars of an impact will that have on the economy? So to do that, we look at how this incident or how this fact, or for example, if you impose a tax, how that would affect the consumers and initially, and if there is any other entity involved. For example, in the case of a tax, the government is involved, or in the case of a tariff. Let me start.
Recording in progress.
Like I said, if you want to analyze the impact of a certain phenomenon like tax, then you would look at how that would have an impact on the consumers as well as the producers or the suppliers. At the same time, in the case of a tax or a quota or a subsidy, the government is also involved. In a government, we would want to see how that has an impact on the government. For example, the government would earn revenue from the tax. And if that's in the case of a tariff, which is a tax imposed on exports or imports, then there's another party involved, the international community or another country involved. So you can also look at how that affect the exporting as well as importing parties, and plus the government if there's an impact on that particular party. Right, so you will look at how the triangle, we discussed this last week. It's all there in the recording, so you can go back and refer if you want to. So let's take another example before we move on to today's lecture. So how would you look at the impact of tax on the market equilibrium? Let's say, let's take the case of a consumer tax. Right, so how would you illustrate that using this figure? Right, so you would start with the original demand and supply curves or the original equilibrium. Let's say we are looking at tax on sugar. Okay, since we're going to talk about tax on the consumers, we'll start with the demand curve. So let's say that this is the original demand curve for the product, the sugar, for a D0. And so let's say the government imposes a unit tax or an excise tax, let's say of 3 rupees per unit or per kilo. Right, so what would that mean? Now, initially, let's say, the consumers, let's say, would purchase this product 10 rupees per kilo, which would be the original price. Right, and 10 kilos per unit. At this price, you could purchase, let's say, 100 units. Okay. Right, so what would this mean now? So now this is how much the consumers would pay in the market. But we know there are two entities, and we also discussed this last week, that the price that is one of the key determinants of demand. I mean, it's actually the key determinant of demand because we draw the demand curve in terms of price. So the price that consumers purchase will be a function or will depend on how much the producers want to sell it at. So then in the market, there are two entities, the producers and the consumers. So in the market, the consumers would. Okay, so I'm going to disable annotation. So try not to draw anything on the slides, please. Right. And so you can see that the consumers pay 10 rupees per kilo and they purchase 100 kilos at that price. And so if the tax price is 3 rupees, so we have to remember that although the government imposes this tax on the consumers, there is an impact on, there's an effect on the producers also. So this tax is borne by both parties, both the consumers and the producers. So effectively, although this is how much the producers pay in the market, how much will although this is the price the consumers pay in the market, how much will the producers get? So that would be 10 minus 3, which would be 7, but for the same amount, right? So let's say when they pay 10 rupees in the market, because of the tax, the producers would only get 7. We know the revenue is earned by the government. And if this price goes up to, let's say, 13 rupees, so say 13, the consumers can demand a certain amount, and effectively the producers would get 13 minus this tax amount, which is 10 rupees. So now you can see that there's an effective demand curve, which this is called an effective demand curve, because this is how much the producers will actually earn in the market, although consumers actually pay these prices, right? So therefore, the tax, we can see, shifts the demand curve. So that also is, goes by the demand theory, because we know that certain things that reduce the demand, certain external factors that reduce the demand will shift the demand curve. We discussed last week. That factors will shift the demand curve outwards, and other factors will shift the demand curve inwards. So tax, because it raises the price, that therefore the consumers are willing to purchase less now, therefore the demand curve shifts inwards, right? So reducing the quantity that they purchase or they demand. Right. So now let's look at the equilibrium in the market. So now this is this demand curve, which we just drew. And the supply curve. We saw that because of the tax. Okay, let's say now this is the original demand and supply. Okay, let's say now this is 10 rupees per kilo, the original price and quantity. 10 star is the equilibrium price, and at that price, let's say people would demand 100, and the tax amount is 3 rupees per kilo, and we now know because of the tax, the demand curve would shift this way, right? So what happens now? Now there's a new demand in the market, demand has shifted, therefore there's a new equilibrium point there. The equilibrium it's the point where the supply and demand curves cross each other. And I'm calling before the tax, this was the original demand supply equilibrium, the market equilibrium. But now, because of this tax, there's a new equilibrium, right? So what does that mean? So this equilibrium would show us how much the producers would get in the market, which is less than 10, let's say 9, right? And now the quantity has also gone down, let's say about 50. It's a little 100 well, then 50 well, and that happens when the price increases. So we know because of the tax, the demand curve shows how much the consumers pay in the market. The consumers pay much higher than the original price because of the tax. So let's say this is about 12, right? Now, the original price was 10, and because of the tax, it has gone up to 12, but the original tax amount is 3. May difference again penna or may difference again, and it's the tax amount, which is 3 rupees per unit. So although the tax is 3 rupees per unit, the consumers don't pay the total amount of 3 rupees. They instead pay 12, and so anyhow the price has gone up for the consumers, but you can also see the price in the market has gone down to the price the producers get in the market has gone down to 9 by 1 rupee. So this entire difference between 12 and 9 is 3 rupees, right? What does that mean? So now this is the tax that the government imposed per unit, out of which a part is borne by the consumers, other part is borne by the producers. And producers that impact consumers that impact. On the other hand, we know when the quantity has also gone down, so definitely this tax has an impact on both the consumers and the producers. So if you want to quantify how much, so we looked at this last week, but we're not going to go into details, but you can look at how this triangle, which we called as the consumer surplus and the producer surplus, will change with the tax. But if you want to also calculate the amount that the government would get, right, it's 3 rupees per unit. And now the new quantity is 50 in the market, 50 trade at this price. Therefore, the revenue the government get would be 3 times 50, which is 150, right? So that's how much the government gets. You can also calculate amount, the cost to the consumers because of this price increase, the $100 and also cost to the producers, because now the price has gone down from 10 to 9 by 1 rupee. Yeah, so that's how you would look at the overall economic impact of the tax to the economy. But like I said, you can illustrate this for any impact. If there's a tax on the supply, if there's a tariff or whatever incident, you can illustrate and quantify using a graph. Right, so that's how you would look at the impact of certain economic phenomena. And okay. Yeah, so I'm going to get rid of this annotation. We discussed the change in equilibrium last week as well. Once you find the original equilibrium, you can illustrate the change in the equilibrium due to certain factors, be it the supply change or demand. For example, if there's a change in supply due to a new technology, mechanization, or change in the labor prices, that you can show change in the supply curve, or if there are any changes that happens to demand, for example, like we discussed the tax, or if there's a taste and preference change, weather impact, and if there's any change, any shift in the demand, we can find how the equilibrium changes and how that would affect the change in prices and price and quantity in the market, right? Right, so now we are going to move into theory of the firm. So under theory of the firm, we will look at 3 types of relationships. Okay, so have a look at, have a read through the slide. Right, so now we are going to look at how a firm would make decisions in terms of production, right? So when we talk about this, we look at 3 types of relationships. We all know that what happens in a firm is that raw material or factors of production we discussed last week, land, labor, capital, and entrepreneurship. So these factors of production are transformed into goods and services, isn't it? So there's a factor-product relationship. Factors are the factors of production, which simply we call as inputs. Then there are outputs, which we call as products. So there's a factor-product relationship, and there are other relationships, but in terms of factors and products, right? Factors are inputs, products are outputs. So the three relationships that we will look at in this lecture is first, we will look at factor-product relationship, factor-product. One, we'll look at factor-product relationship or input-output relationship. Then second one would be what? Look at factor-factor or input-input relationship. Then third, we will look at product-product relationship. Right. So factor-product relationship, input-output, right? So why is this important? Because especially if we know if we are working in the food and agriculture sector and we deal with production of goods or services, we know any, be it agriculture or any other sector, if you look at production, the outputs depend on the inputs, isn't it? Outputs depend on the input. Output damot tama input ekak enne, right? And output input එක වැඩි කරනකොට හෝ අඩු කරනකොට, if you vary the amount of input, that would affect the amount produced, right? So we can model this relationship using a factor-product relationship, and that's what you see here. So we know by now that in economics, we deal with or we work with models, mathematical and statistical models, and because we want to quantify, right? One is we want to quantify the amount or the magnitude or the size of the impact, and at the same time, these models help us to predict, right? Or even forecast what would happen in the future. Now here what you see is a relationship between inputs and outputs. By now, you know what we mean by a function, right? We discussed the demand function. First take a demand function discuss karabe model versus supply function. Now here we have what we call as the production function. Input-output relationship is shown using a production function. So what you see here in notations here is a production function. So what do you find? You can see that on the slide. Production involves transformation of inputs such as capital, equipment, labor, and land into outputs, which are goods and services. So if I want to think of, okay, you can think of what factors would affect the output of a crop. Right, so let's take paddy, for example. What factors would affect the output or the yield, in other words, the yield or the output of paddy? Now, Q here on the left-hand side, Q is the output, or let's say the yield of paddy. Now, I'm just taking examples of crops, but it could affect, can be applied to any product, right? It could be a product that's produced inside a firm, inside a plant, a factory, right? But since we are focusing on agricultural products or food products, we'll take an example of a crop. So if you take paddy as a crop, there are certain factors that affect the production, right? What factors would affect the production of paddy? Now, so most of you, some of you at least, must be working in production. So you would know, or even that's common sense, isn't it? What factors would affect the production of a crop? Paddy production එකට, paddy output එකට, නැත්නම් paddy yield එකට බලපාන සාධක. Now, If you ask me, the first thing I would think of is fertilizer, isn't it? Fertilizer ප්‍රමාණය මත paddy quantity එක වෙනස් වෙනවා. Fertilizer අපි දැක්කා fertilizer නැති වුණොත් මොකද වෙන්නේ? Right? Fertilizer වැඩි වුණොත් මොකද වෙන්නේ කියලා අපි දන්නවා. එහෙනම් fertilizer would determine the amount of crop produced. What else? Right. So I hope everyone's awake. Can you send me a few answers in the chat box? I mean, last week I got quite a lot of responses from you, so just send me a few factors that would determine the quantity of yield, right? One would be the fertilizer, for example. Water, amount of water. Very good. Yes, water. Land, the amount of land. Very good. So if you have 50 acres of land, and that would give you some amount of yield. If you increase it to up to 75, that would increase your yield, right? Potentially. So water, land, very good. Air, those are all natural resources, aren't they? What else? Labor, the amount of labor. Seasons, you might have an abundance of labor. Some other seasons are not even economic crisis in the labor issues the end of. So if that happens, the amount of labor will affect the amount of paddy produced, right? What else? Certain government interventions, subsidy එකක් දුන්නොත් farmers ලට I mean නැත්නම් quota එකක් හින්දා අපේ මොන විදියකින් හරි මේක limit කරොත්. So government interventions would also affect අපිට කිව්වොත් quality certification එකක් හැමෝම adopt කරන්න ඕන. All farmers must have a GAP certificate කියලා කිව්වොත් that's going to affect our production, because having a GAP certificate or any certificate for that matter is going to be very expensive. So in the short run, that might have a negative impact, but in the long run, that might even help to increase your production. We don't know. We can just hypothesize that would have some sort of impact on your production. What else? Mechanization, machines, mechanizing your farm, diseases, very good. The variety of crop, good. The pest and disease attacks can have an impact on your output, doesn't it? So weather. So now that's a very good factor that affects the production, because we know climate change definitely affects, or climatic factors or weather factors will affect the production of crops. So since we are dealing with agriculture, crops or livestock, we know that would have a major impact. So pest and disease attacks, weather impacts will determine the amount of output that's produced. So now if you write all those factors as in the form of a function, like what you say here, we call this a production function. This entire function, that would help us to quantify the impact. This is what? Labor. K is capital. R, raw material. LD is land. T is technology. Then simple T, time. For example, if you want to, let's say, forecast what would predict what would the quantity be in 5 years' time, you can do that by using time series data. We can collect data for the last 10 years or 20 years using records, and we can predict the potential yield for the next in 2 years' time or 5 years' time, right? We can also include certain other factors. We know weather factors, climate change factors, landslides, rainfall pattern, pest and disease attacks, or government intervention, tax, tariffs, subsidies. So these factors can also be included. Factors model all you have to do is you have to collect data, and using a software, we can statistical software package, we can run this model and identify the magnitude or the impact of these factors. Rainfall pattern, what would happen to the quantity. Right? අඩු වෙනවද වැඩි වෙනවද? Labor charges වැඩි වෙනවද? Labor quantity එක වෙනස් වුණොත්. How that would affect the quantity of the crop produced. So that's what we will be discussing under factor-product relationship. Okay, now here, so what have I done here? I have drawn or I have plotted the yield of a crop, let's say paddy, against an input. First we take one factor at a time because we are trying to learn what happens in this scenario. But if you're doing this as an actual research, you can analyze all these factors together. But now we are going to take one factor at a time. Let's take the relationship between the crop output and one factor out of these factors. Fertilizer, right? So what would happen? So if you plot, fertilizer, if it's a crop, fertilizer would be the key input, right? So what I have done here is I've plotted the relationship between yield and the amount of nitrogen or any fertilizer, right? So what type of a graph, what shape of a graph would you expect if you plot this relationship? Crop you would gradually increase the amount of fertilizer, right? Over the season fertilizer pramane වැඩි කර final yield එක estimate කරනවා. එක්කෝ bushel selling or kilo selling එහෙම නැත්නම් fruit එකක් number of fruit that you get, nuts or whatever. කොයි විදිහකින් හරි අපි record කරනවා ඒ අදාළ nitrogen ප්‍රමාණයට corresponding yield එක. Right? So if you do that on paper, what type of a graph would you expect? Now, if you've studied science in your A levels, this graph is familiar to you. What do we call this graph? Or what shape actually? What is this shape called? Yes, good. It's sigmoidal, isn't it? Sigmoidal shape. When did we draw, or when do we come across a sigmoidal shaped curve in terms of in biology? When you look at growth, isn't it? Growth of a crop. For example, you would see a sigmoidal shape. Why does that happen? Right? So if you look at the output-input relationship, now make that output-input relationship, but if you look at the output-input relationship of a farm of a plant, let's say, right? Within plastic production, tin products, canned products, production plant. If you have yield or output on this side, let's say output, and if you have any raw material on this side, input-out relationship again, though, you will see something like this, for example, because when you have zero input, you have zero output. Linear zero output එකක් නැත්තම් plant එකක් in the factory production එකකදී input එකක් නැහැ. අපි textile ගත්තොත් raw material විතර cloth දුන්න නැත්තම් there is no output. So that's a very technical relationship. When you have no inputs, there are no outputs produced, right? But when it comes to biological relationships in agriculture, like crop production, livestock production, right? The conditions are different, right? For example, even if you, let's say you plant or you grow a crop, and if you don't add any fertilizer, there might be some yield, right? The plants would still grow. It would absorb the fertilizer, the nutrients from whatever is available, remaining amounts in the soil, and it would still grow, and you might even get a yield, වැඩි yield එකක් නැතත් යම්කිසි growth එකක් වෙන්නනවා. Right? Unlike in a very technical relationship, what would happen in a plant or a factory, right? Livestock ගත්තත් එහෙමයි. Even if you don't feed your hens, you might still get eggs, right? Milk production, egg production, livestock වලදීත් එහෙමයි. So it's different, and the growth is also different, right? What would happen if you keep increasing the amount of nitrogen fertilizer? Zero, you don't add any fertilizer in the beginning, but you would still see a yield or a growth, right? Some amount of growth. And then you keep adding fertilizer gradually, 1 unit after the other. Each time you add 1 unit, so 1, 2, 3, 4, likewise, you keep adding 1 extra unit of fertilizer, nitrogen. And you will see that initially the crop would grow at an increasing rate. At an increasing, it increases at an increasing rate, the yield. And then after a point, we call this, it initially increases at an increasing rate. And then it's still increasing, the yield is still going up. That now the yield increases at an increasing rate, and then after this point, the yield still increases, but we say that yield increases at a decreasing rate. Then yield එක වැඩි වෙනවා, හැබැයි අඩු වෙන rate එක වේගයෙන්. Then it comes to a maximum. අපි හිතමු මේක 6 units per. This is 5 and this is 6. 6 unit එක දානකොට තමයි අපේ maximum yield එක අපිට ලැබෙන්නේ. So now you can see, as you increase the amount of fertilizer, if you add an additional unit of fertilizer each time, the yield increases at an increasing rate, and then after this point, it increases at a decreasing rate, comes to maximum. Maximum yield yeah, comes to a maximum, and then what happens? If you add more and more fertilizer, if you add more and more fertilizer, your yield will start going down or decrease, right? But this is true, isn't it? So that's why, if as agronomists or horticulturists, you are you're interested in knowing the optimum amount of fertilizer. As economists, we are also interested in understanding the optimum level of fertilizer for different reasons, right? Why? Why is it important for us to understand the optimum amount of fertilizer to use, right? So that's why if you're studying if you're studying a diploma in agriculture or a degree or a postgraduate degree, you also study, especially a degree and diploma level, you study the basic science of agriculture, of crops, crop biology, what else? Agronomy, horticulture. So you understand the science behind this, the anatomy, the biology and all that. And then in order to make the right decisions, you also want to understand the economics behind it, right? Because at the end of the day, we are dealing with agribusinesses. It comes to production. It could be the raw yield that you sell, or it could be a value-added product. However, in order to make the right decisions, we also need to understand the economics behind the production. So now we know that the plant grows in such a way, right? And so where do we stop the amount of fertilizer? So this is economic impacts. Why? Because one, fertilizer is priced, right? It's priced, it's expensive. It's not given free. Therefore, we need to determine the optimum amount. Fertilizer cost. It's costly, right? You have to pay a price for it. So from that point of view, also you need to know it's good to know the optimum amount to use. On the other hand, if you add extra fertilizer or more than what's needed, it could be poisonous to the tree. And that could reduce your yield, right? And also that could have other implications, right? If you have more than what's required, it might leak or leach into the soil, and that would pollute the area, that would have health impacts on flora in the area, the fauna in the area, humans. There's a lot of impacts of this. So if you are doing an actual economic analysis, you can consider those factors as well. But coming back into the production function, so we are looking at the input-output relationship, but now we know that the plant or the crop, or I'm only referring to a crop, but this would apply to any biological relationship, milk production, meat production, egg production, or whatever, right? So we can say that as you increase the amount of fertilizer, the methanol, fertilizer this could be water, labor, any factor, right? But for the example, we are taking nitrogen and output relationship. So you can say now this is how it grows. So we would want to know the optimum amount. So how do you decide on the optimum amount is the question, right? So to do that, any questions up to this point? No? Right, to do that, we're going to look at certain conditions or certain factors that we need to understand, right? So when it comes to production or factors of production, now we're looking at input-output relationship. We can divide inputs in economics into two key types or two categories. One we call as the variable inputs, the other are called fixed inputs. What's the difference? So you would have read by now that variable inputs, the definition is farmer, although I say farmer, it could be any decision maker, right? It could be you yourself, if you have your own firm. It could be a farmer, it could be a manager of the firm, right? The decision maker, we say, can control or alter the level of use. The farmer has sufficient time to adjust the amount of input being used for a variable input, right? So what it means is the decision maker or the farmer can control or alter the level of use, and he has sufficient time to adjust the inputs being used. Fixed inputs, on the other hand, the farmer has no control over the amount available and has no sufficient time to adjust the amount of input being used. Right. To understand that, we also need to know that in economics, we also talk about two, or in some books, we also talk, you would see 3 time periods, but initially we will talk about 2. Right? When you take time, we categorize the time into 2 as long run and short run. Right? So, short run and long run. Right? We say variable inputs, the farmer can only vary the variable inputs in the short. And a short run you find, let's call this variable inputs and this is fixed inputs. And you find both variable inputs and fixed inputs. In the long run, we say you only have variable inputs because even the fixed inputs will become variable. And a short run again, types, two types, variable inputs and fixed inputs, right? So the short run and long run, if you ask me how long, like 5 years or 10 years, that would depend on the type of the firm, right? Type or depend on different factors of the firm. But we say in the short run, the farmer can vary the amount of inputs used. Can you think of examples? Let's say the short run is a season, right? May season the paddy produce the farmer can easily change variable inputs like the amount of fertilizer, the amount of labor, the amount of water. Now these are easily variable, right? මට අඩුවෙන් ගහන්න ඕන නම් ගිය පාර සීසන් එකට වඩා අඩුවෙන් fertilize පාවිච්චි කරනවා නැත්තම් anyway the idea is that you can labor season එකේ අඩු වුණොත් අඩුවෙන් labor පාවිච්චි කරනවා. So variable inputs are variable in the short run, but fixed inputs we say in the short run the farmer cannot change. For example, building or machines. Let's think of a few examples.
Recording stopped. Recording in progress.
So we were talking about the two types of inputs, variable and fixed inputs. So we categorize in terms of the length of the period, right? Long run or short run. So we said that, for example, a variable input, a farmer has control over. A farmer can vary the amount of variable inputs in the short run. For example, fertilizer, labor, water. So these factors you can change as you wish, right? But fixed inputs, on the other hand, fixed inputs are things that farmer has no control over the amount available in the short run. For example, the land, right? Buildings. Now, if you take 1 year within let's say 6 months. 6 months is a season, and in that season, you can change the variable inputs like labor and fertilizer and so on. But even if I want to change the land area, right? Let's say I want to increase the land. Maybe I have 1 acre, but I want to increase it up to 2. I can't do that in 6 months as a small scale farmer, let's say. So therefore, land is a fixed input for me. In 6 months, land is a fixed input because I don't have money to buy more land expand my production. I cannot increase the amount of land. Therefore, it's a fixed input. Building input, even if I want to buy or build another input or rent another building, I can't do that in 6 months. Therefore, it's fixed. Machines could be fixed, right? So variable are things that you can vary in the short run, whereas fixed inputs are inputs that you cannot vary in the short run, right? But in the long run, let's say 5 years is the long run, and the variable inputs, or sorry, fixed inputs, they couldn't vary in the short run. Those also become variable in the long run. Vary කරන්න බැරි වුණ inputs තියෙනවා නම් buildings land වගේවත් vary වෙන්න පුළුවන් 5 years වලදී. එහෙනම් long run එකේදී you only have variable inputs because both in fixed and variable inputs become variable in the long run. හැබැයි in the short run you have two types, variable and fixed inputs, right? Okay, any questions? Right. So we need to understand, or we need to know a few things in order to calculate or compute the optimum amount of fertilizer to maximize profit. Because at the end of the day, right, or the objective of any firm or any agribusiness is what? Like you are in the first day also, like the objective of a producer or a supplier or a firm is to maximize profit, isn't it? You want to maximize profit. How would you maximize profit? By increasing the revenue and minimizing the cost, right? Maximizing revenue and minimizing the cost, and that difference is the profit. So you would want to do one of those or both in order to maximize your profit, right? So how does this work? In order to calculate this optimum point, when you look at the production, now if you look at the output, we're looking at the output side now, in terms of input, of course, but we are going to derive 3 relationships. So in the first column in this table, you see the number of workers. So that's the what? That's the input, isn't it? Now, what you see here in this first column is the input. Input or factor, because factor product relationship again first, workers would be your input. So you are increasing, or you are adding, or let's say employing a worker each time. So let's say you start this business with 1 employee, and with that employee you get 24 tons of output, paddy or wheat or whatever the crop. This is the output, the total output, total yield, harvest, whatever. When you employ 1 employee or 1 worker, you get, let's say workers, because it's going to be variable input. So 1 worker, you get 24 tons of output. Then you employ another worker. Production process. You get 72 tons of output. Right? Workers total product the yield is also increasing. 138. Fourth, 216. Fifth, 306, 384. Likewise, the relationship. Now, have a quick look at this relationship, the numbers. What type of a relationship can you spot from these 2? Right, we can see that as you employ an extra worker each time, එකෙනෙක් වැඩිපුර employ කරන හැම වෙලේම total product එක එන්න එන්න වැඩි වෙනවා. But when you employ the 10th worker, you get the total output is 600. And you employ the 11th worker, the total output has gone down. So you have more than what you need on the field, let's say, right? That could affect the final output. So if you plot it on a graph, it would look something like this. 10th worker again pass 11th එකනා දැම්මට පස්සේ එන්න yield එක අඩු වෙන්න පටන් ගන්නවා. Right? So that's the relationship between this input and output relationship, or output, behavior. And now using that, now in the first two columns, what we have done is we have drawn, or we have plotted the relationship between F stands for function, relationship between input, Q කියන quantity of output කියන එක. So output or yield, whatever මොන හරි අවසාන yield එක හරි output එක හරි, right? Q. Now Q depend on අපි ගත්ත fertilizer ප්‍රමාණය මත. Now we'll call this input or fertilizer කියලා කියමු අපි. So it's easier for you to understand. Fertilizer ප්‍රමාණය මත depend on. In this case, it depends on the number of workers. Yeah, output එක අවසාන output එක number of workers ලා මත depend වෙනවා. N කියලා කියන්නේ workers. So if you plot this on a graph, the graph that you get is similar to the sigmoidal shaped this one graph, this one. Right. So using this relationship, we need to know two other things. We want to calculate the average product and the marginal product. Average product එකයි marginal product එකයි අපි calculate කරනවා. Now this is called the total product. Total yield එක එහෙම නැත්නම් total output is called the total yield. TP is total product, TP in terms of L කියලා කියන්නේ labor, but don't worry about that. TP කියලා කියන්නේ total product. Simply it's the total yield, right? Or the output. Now from this, we are going to make it a total product එක. මුළු product එක දැනගත්තට පස්සේ අපිට පුළුවන් තව relationship එකක් හොයාගන්න. ඒකට අපි කියන average product කියලා. Now we all know the term average, AP, average product. Average කියලා කියන්නේ මුළු ප්‍රමාණය workers ලා ගානේ බෙදුවහම, right? So average product is, how would you calculate the average product? Is this total product quantity එක final yield එක number of workers ලාගෙන් බෙදෙනවා. නැත්නම් total product එක number of workers ලා ගානේ බෙදෙනවා. එතකොට number of workers, the total product divided by the number of workers, what does it give you? It gives you the output per laborer or worker, right? එක laborer කෙනෙක්ගෙන් ලැබෙන output එක. එක worker කෙනෙක්ගෙන් ලැබෙන output එක. Now the output per number of laborers or workers. So let's say now the total output is 10. If you divide by, if the number of workers are 5, you get the number of output or the number of fruits per worker. Okay? So it's simple as that. Then you calculate the average product. අපිට බලා ගන්න ඕනේ එක input එකකට ලැබෙන output එක. එක fertilizer unit එකකට ලැබෙන yield එක. එක laborer කෙනෙකුට ලැබෙන yield එක. Right? That's the average product. And then you want to calculate, now this is done. Now we also want to know the marginal product. Now this term is familiar to you. Right? We discussed the marginal utility. Okay? So like I said, this term margin or marginal is very important to economics, because you will see as we talk about the pricing strategies, cost theory, margin is very important in decision making, right? Marginal product. What it simply means is that is the amount of the output, the additional output that you get when you increase one work, right? එක work කෙනෙක් වැඩි කරාම ලැබෙන additional output, marginal product. Right, so how do you find the marginal product? It's the change in total product is to a change in N. Right, so if you are familiar with basic mathematics, you would have heard of differentiation. So we say, if you're actually calculating this in an actual study, we differentiate this function to find the marginal product. But don't worry about that. What we're trying to say is, how do we calculate this? The change in total product to a change in the number of workers. Right? Okay, let's try and work out the first one. So how would you find the average product when you add the first worker? It's easy. 24 is the total product divided by 1. Right? This is 24. How do you find the marginal product? Now here, of course, increases from 0 to 24 divided by 1. So 24 minus 0 divided by 1 is 24. Now, when you add the second worker, it's 72 over 2. And here it's 72 minus 24. And I'm making my card parallel. That we divide by this difference, 1. Minus 1. Right? So that would be the marginal product. Now I'll give you a few minutes. Just try and work this out. And let's check the answers together.
Recording stopped.
Answers. Now that you have the average product values and the marginal product values, just try to plot the values on a graph. Right? It doesn't have to be proportionate, but try to plot it on a graph and see how the behavior, the average product and the marginal product would look like. Right? If you plot these values on a graph, try plotting all three, the total product, marginal, and the average product on a piece of paper. See how it looks like. If you look at the number of workers and the total product, we know it varies or it takes the shape of the sigmoidal curve, right? If you plot average product, or if you look at the numbers, you can see as you increase the number of workers one after another, the average product increases. Average product of a calculator, average product is simply the total product divided by the number of workers or the input. So you can see the number of workers, or the average product increases with the number of workers up to this point. Up to the seventh worker, seventh it becomes 66, the average product, and 8 also is the same. But once you add the ninth worker, it starts decreasing, right? ඊට පස්සේ මේ වෙනකම් වැඩි වෙලා මෙතනින් පස්සේ අඩු වෙන්න පටන් ගන්නවා, right? So total product also it increases up to the ninth worker and then it starts decreasing. What about marginal product? The marginal product also increases with the number of workers. පළවෙනි කෙනාගේ ඉඳලා add කරගෙන යනකොට marginal product එක එන්න වැඩි වෙනවා. Comes after the sixth worker, once you add the seventh worker, the marginal product also starts decreasing. Right. So let's plot all these three relationships on one graph. Okay. So now this is what we are familiar with, the total product function. Total product again in the value now. Average product marginal product also comes to a maximum and starts decreasing, right? So we can calculate all this using data, and once you do that, we can see that as the total product comes to a maximum yield marginal product becomes 0, right? Marginal product becomes 0. Right? Now, this you can prove algebraically also when the slope of a curve is at its maximum or a minimum point. The total product, or when a curve is at its maximum or minimum, the slope becomes 0, or slope is 0. And the marginal product is the slope of the total product function, so it becomes 0 there. So don't worry about it if it's too much. But what we want to understand here is that as the total product is a maximum, the marginal product becomes 0. It passes total product you can see the marginal product becomes negative. So what is marginal product? It's the additional product that you get as you increase one extra unit of when you increase 1 unit of the input. Input එක unit එකකින් වැඩි කරනකොට වැඩිපුර ලැබෙන product එක. That is called the marginal product. Right? The marginal product increases, comes to a maximum, and then slowly it decreases and it becomes 0 when the total product is at its maximum. ඒක තමයි relationship. Right. So now the question is, where should you produce to maximize profit? So as economists or as managers or as business owners, we are interested in identifying where should you produce to maximize profit, right? So how do you find that point? Now, how do you maximize profit? To understand profit, or to calculate profit rather, profit, let's say profit equals revenue minus cost, isn't it? Revenue minus cost. So our revenue and cost would depend on the amount of fertilizer that you use. Cost එක depend වෙන්නේ මෙතන එක product එක input එකයිනේ තියෙන්නේ. So if this is fertilizer, අපි කියමු මේක fertilizer කියලා, or workers or whatever, right? Any input. So this would depend on the amount of fertilizer, give X කියලා, and price of fertilizer. Right? Price එක අඩු වැඩි වෙනකොට අපි දන්නවා cost එක වෙනස් වෙනවා. එහෙනම් the market price එක හොයාගන්න පුළුවන්. You can easily find the unit price of fertilizer. අපි හිතමු කිලෝ එකක හරි bag එකක හරි unit price of fertilizer you can find from the market. That unit price is PX, price of fertilizer, times X is the amount of fertilizer. Now revenue we know is depending on the make a pineapple kilo. Pineapple yield එක නම් pineapple harvest එක the yield එක මත depend on number of pineapples, right? Or banana, nuts or whatever, paddy, bushels or kilos or whatever. So if this is pineapple, the number of fruits that you get, the number of pineapples, a bit of a y kilo amount, the higher times price of the pineapple that you sell in the market. So that we know by price of y. So that would give you the revenue minus cost. This difference is the profit, right? So when you maximize this function, the profit take a maximum when a point you can actually solve this equation, right? And you will come up with a simple equation like this. The marginal product times the output price, pineapple ekaka mila, price of a pineapple equals the price of a unit of the input, right? Marginal product equals times price of pineapple ekaka mila equals the unit price and the unit price of the input ekaka mila. Right. So once you find that, you can find the optimum point. Now, what we need to understand is, again, we can look at two scenarios. One is what would happen if fertilizer is given free of charge. Nikang dunna fertilizer. Now, we can apply the same principle to understand what would happen with a subsidy, fertilizer subsidy, right? But in this case, let's say it's free, not even a subsidy, it's given free, not priced. We say that if something's given free, if fertilizer was given free, the farmer or the producer can reach the maximum yield, right? It can reach the maximum yield if it's free, because it doesn't matter. It's given free. You can use any amount of fertilizer until you get the maximum output. Now we can find that as the values are there, we can find how much Y is produced. Pineapple, the maximum amount. But that's one scenario. The second scenario is when it's priced. We know nothing's free, so it's both are priced, the output and the input. Therefore, when it's priced, what would happen? So when it's priced, you will have to find, or we say we settle for an optimum point, not the maximum, but we will have to settle for an optimum point, and we say that it happens in stage 2. So if you want to read on further on this, if you're interested in reading, you can you read up on why stage 2 is the best range to produce. This range in the production function is the optimum range to produce. A range produce. To identify that particular point, we can apply the data, or we can substitute the data, or we can solve this equation. Equation solve point exact point range. Right? So we can see that as the prices increase, for example, fertilizer price shift point, right? So we can see that when the market prices change, these points will shift. Okay. So as a farmer or a producer, we say you don't stop in stage 1. You don't stop in stage 1. Why? Because we say that it's irrational to stop, because we can see as you increase the amount of fertilizer, your output increases. Input මේ range එකේ output එක වැඩි වෙනවා. තවත් දුරටත් වැඩි කරන්න පුළුවන්. We can still further increase the output level. Therefore, you don't stop production at this point. You go into stage 2. Do you produce in stage 3 or should you produce in stage 3? Yes or no? Can someone yes or no? No. Good. Why? Because we can see that you increase the amount of fertilizer, but the output is decreasing, isn't it? So you don't produce in stage 3 either, because it's irrational to produce in stage 3. Why would you want to produce? You increase the fertilizer, your output is going down. So there's a cost involved in terms of purchasing the fertilizer. And if there's too much of fertilizer, that's going to affect the environment and so on. So it's irrational to produce in stage 3. No rational farmer would do that. So you can see the only viable area, we say, is stage 2. So in stage 2, you would want to identify the exact point, and that would depend on this particular function. You substitute the values to this function, and you can find where to produce the optimum point of the weather kiln, right? So that you can find if you find that, you can find the optimum amount of fertilizer to use and also the optimum harvest that you get, the number of pineapples or whatever, right? So that's how you find the optimum amount of production. Now, we did this manually using a graph, but if you want to get precise values, we use model or mathematical relationships to derive this function and find the optimum amount of fertilizer and output. Okay? Just for your knowledge. So that's how you do that. Right. So now we looked at the first type of relationship, input-output relationship. Oh, and also there are packages to find optimum fertilizer amounts. So then that's done. Now we look at the second type, factor-factor relationship. Right? Factor-factor relationship. What are factors? Input. So we will look at the input-input relationship, the theory behind input-input relationship. Right. Right. So in the previous lesson, we looked at input-output relationship, one input, one. Now we're going to look at the relationship between two inputs, right? Two inputs and one output, actually. Because we know, let's take a crop. You need more than one input, isn't it? You need, for a crop, you might need fertilizer, water, labor, seeds, right? So lots of inputs. So now we're going to look at how do you find optimum production given two inputs and one output. Right? So factor-factor relationship. So here it's relationship between output and one input, but now we will look at output in terms of using or when you use two inputs, X1 and X2. It could be what? Two fertilizers, let's say potassium or potassium nitrogen fertilizer, or potassium urea, or it could be water, it could be labor and capital, whatever. We're going to look at two inputs and one output production. Right. Now look at this graph. What have I done here? Okay, now here you have two inputs, labor and A stands for capital, L stands for labor. So you have two inputs. Let's say you are producing using labor and capital. The inputs දෙකම use කරලා ලැබෙන output එක අපි plot කරලා තියෙනවා table එක. Now when you use one unit of labor, එක labor කෙනෙක් සහ capital units 8ක් use කරලා it could be financial capital or machinery, machines 8ක් or whatever, right? You get 37 units of output, crop, livestock, any output, right? So you get 37 units. Now then, 7 units of A and 1 unit of labor get 42. Now here you employ one unit of capital and 8 units of labor and you get 17 units. Or you can plot the amount of output you get when you use different combinations of input. Right? Make combinations with the bundles, when bundles use output level vary. And I have plotted or I've written all those output amounts on this matrix, this table. Right. And then what I have done is I have picked the output levels, the similar output levels, right? For example, now if you take 6 units of K and 4 units of L, you get 73 units of output, right? Again, if you take 4 units of K and 6 units of L, you still get 73. Again, 3 units of K and 8 units of L, you would get 73 again. So what I've done is I have connected those points and drawn a curve, right? 52 tiana output level like a curve 29. You might be able to spot a few more. Any other points here? 58 and 58. Yeah. So I can draw a line there. So likewise, you can find similar points. Now, if you draw a curve connecting those points, we call that isoquant. Iso means same, quant means quantity. Same quantity curve is called an isoquant curve, right? So now we can see with different combinations of inputs, you can have the same amount of output. Now let's take one curve out. So if you draw several isoquants on the same graph, it's called an isoquant map. Now if you take one out, let's take one. I'm just going to draw one isoquant. So you have x2 on this axis, x1 on this axis. And I'm hit them up to 70, 52 kilo, 52 kilo yield level. Now, irrespective of the combinations that you use, you would still get 52. Right? May combination got that, may combination got that, 50. Same yield. Right. Now let's say I have an abundance of x2 and I use this much of x2 and use this much of x1. And then maybe I have more of x1 this time, and then I want to increase the amount of x1, but I want to get the same amount of yield. And to do that, if I increase one, I will have to forego the other input. Like a fertilizer type of fertilizer, urea and potash. If you increase the amount of x1, you have to reduce the amount of x2 to get the same yield. But what would happen? So what do we see here? We see a trade-off, isn't it? We see a trade-off when you increase x1, you reduce an amount of other input to be the same yield level. But let's say now I want to increase both, right? I increase x2 and x1. දෙකම වැඩි කරනවා. දැන් ඉස්සෙල්ලා අපි එකක් වැඩි කරනකොට අනිත් එක අඩු කරන්න උනා. එකම yield එක ගන්න. Now if you increase both, මොකද වෙන්නේ? Here. Now you can see we can move to a higher or greater output level. Let's say this is about 60 and now 52 and there are 60 if you increase both, right? So as a producer or as a farmer or as a producer, we know that our ultimate objective is to maximize profit. So to do that, we would want to increase our output, isn't it? Output is 6. There might be one level, 61, 70, 80. Likewise, you would want to increase your output 70, right? So likewise, you might want to increase the amount of output that you get by increasing both the inputs, right? Okay, one more thing. Now, we call this here, when you increase one input, 52 yield level, when you increase one input, you reduce the other input. And that is shown by the slope of this curve, which we call as the marginal rate of technical substitution, right? So that's the rate of substitution at which one is substituted by the other. So you can see now these substitutes, isn't it? One fertilizer can be substituted by the other. They are not perfect substitute. Nitrogen and potash, they come a fertilizer now. They have different, they serve different purposes. So you can use them as fertilizer. They are substitutable, but they are not perfect substitutes. Perfect substitutes, never. That's why this curve is it's a curve and not a linear straight line. But okay, don't worry about that. But what I'm trying to say is now that's the slope. Anyway, a farmer or a producer would want to increase the amount of increase the amount of output that you get. That a farmer කෙනෙක් විදිහට මගේ wish එක තමයි පුළුවන් තරම් මගේ wishes තමයි or my wish is to increase this level of output. Okay? Right. So can you think of a similar graph that we discussed on the first day? Something similar that we discussed under demand theory? Right. So can you remember the indifference curve? So it's similar, isn't it? But except now we are talking about the producers, decision making, theory behind production. But there we talked about utility in terms of demand. But now, so the theory is very similar, except that we looked at utility when you consider two products at the same time. Now here we are looking at output when you use two inputs. Right. So now isoquants are downward sloping. They are negatively shaped. Why? As we can see, when you increase one input, you have to give up the other input to get the same level of yield. Now, as producers, we want to increase the output. Then make graphic later. We want to increase to 52, 73. Likewise, you won't want to increase. But we, again, as producers, just like in the case of consumers, we are also limited or constrained by certain limitations in the market, right? We can think of lots, but for our convenience, we are only going to take two limitations. What are those two constraints? What would limit your production? අපි කොච්චර කැමති මේක push කරගන්න, we are limited. We have to be satisfied with a certain level of production, mainly due to cost in terms of the budget that you have and the prices of the outputs, right? Price x1, x2 can fertilizer දෙක නම් අපි පාවිච්චි කරන්නේ price of x1 and price of x2. And the amount of budget that I have in my pocket. I will have to spend those two on x1 and x2. This ring a bell, Arvin? Is this familiar to you, this equation? We did something similar last week. Okay, you might want to recall the budget line we looked at last week. This is something similar, but now we are considering, or we're looking at the producers and their cost in terms of purchasing inputs. Therefore, we call this ISO cost line as a cost line. So I'm not going to derive this again because we did it last week. It's very similar to the budget line. So now this curve shows the cost of the producer. Cost function independent. And this shows our wishes. Isocon line එක පෙන්නන්නේ අපේ production එක. Iso cost line එක පෙන්නන්නේ cost එක. එහෙනම් අපිට optimum production එක හොයාගන්න ඕන. Now we know we are limited by the market prices and the budget. Therefore, to find the optimum product, you will have to draw both curves on the same graph. So I plotted the isoquant and the isocost curves on the same graph, and then you find the point where these two are tangent to each other is the optimum point to produce. Now, optimum x1 and x2 then z killer, but let's call it x. We denoted inputs using x, so x1 and x2. Fertilizer 1 again kochara amount ekakda, fertilizer 2 kochara amount ekakda, to minimize the cost so you can maximize the profit, right? So that's about cost function. Right, any questions up to this point?
Recording in progress.
Any questions? No? Okay. Right, so we now looked at two types of relationships. And now we're going to look at the third one. Okay, the product-product relationship. Okay, so now the third type of relationship that you would find in a firm is the product-product relationship. We know that a firm would want to produce more than one product. Maybe you would want to go for two types of crops. Let's say coconut and pineapple, or banana, or two types of the crops, or you would want to go for paddy and livestock, or coconut and livestock together. So two enterprises or two product might be produced, or two value-added products, right? Canned products, two types of canned products. So two products, when you produce more than one, in this case, we are only going to look at production of two products. How would you identify the optimum amount of products to produce? Right? So how would you find the optimum amount of products when you produce two products at the same time? Now, this is a very important graph in economics when you study economics. This helps us to understand so many different concepts in economics, like the opportunity cost. We can apply the same theory to look at why countries should trade, how much to be produced, and how to, the comparative advantage of products, and so on, right? Because you can apply the same theory to the entire economy. But for now, we are going to take a firm, right? So what is meant by a product-product relationship? Or how do we illustrate this product-product relationship? A production possibilities or a frontier is used to show this relationship, and it shows alternative ways that an economy can use its scarce resources. Now, although it says economy, we're going to apply this to a firm, but think of the economy, right? Think of the Sri Lankan economy, but we want to decide whether we are going to produce tea, just tea and nothing else, or whether we are going to produce tea and paddy, or tea and any other industrial product. So given the resources, because we are limited by resources, because we have scarce resources, we have to think of the optimum products to produce. So to understand this theory, we are going to discuss this using the product-product relationship or a production possibilities curve. Right. So how would you draw the production possibilities curve? Okay. Now here is a simple PPF or production possibilities frontier. If you draw one, it's called a curve. If you draw, for example, this is a curve. If you draw several curves on the same graph, it's called a frontier, right? So let's take this simple example. Two products produced in a firm, bikes and wheat. Now let's say this firm starts off with bikes, right? Now let's say there's an abundance of labor, and this economy or this firm produces bikes only. Mulimma, they are not producing any wheat, zero wheat. So zero wheat produce karane, mulimma padangane bikes. So they produce, when you using all the labor, let's say labor use you can produce 14 bikes, right? No wheat at all. Initially, you produce bikes. Now, when you produce bikes in this farm, all the labor, let's say labor is limited, right? Labor is limited, scarce. Therefore, you train all your labor to produce bikes. Now, they are trained to produce bikes and not wheat. But let's say now this firm identifies there's a potential for wheat market, and now we are going to produce wheat also in this firm. Right? So when you produce two extra units, 2 units of wheat, using the same number of labor, because we have to assume that the labor amount does not change. Labor, when rattaking and labor when a given period that labor amount does not change. Right? It's fixed. So then මුළු labour use කරලා දැන් අපිට products දෙකක් හදන්න වෙලා තියෙනවා. එකක් wheat අනිත් එක bites. So you produce 2 units of wheat and how many? 12 units of bites. Now you see, now we have to take people out of bike production and employ them in wheat production. So these people have been trained to produce bikes. දැන් මේ කියන theory එක අපිට economic එකටත් apply කරගන්න පුළුවන්. Now people are trained to produce bikes. Now you take them away to produce wheat. දැන් මේ bikes හද train වෙන කට්ටිය තමයි wheat හදන්න පටන් ගන්න. So initially you take the best people who are capable, who might have a high intellectual capacity. ඉක්මනට train කරලා ගන්න පුළුවන් හොඳම group එක තමයි අපි මුලින්ම wheat වලට දාන්නේ. So these people will take time, it will take time, but their skills are different than ඒගොල්ලෝ මේකට පුරුදු වෙනවා. So now, because we're using the same labor, technology නැත්නම් we will have to give up on bikes. Now we produce more wheat, but we are giving up bikes. Bikes අපි දෙකක් අඩු කරන්න වෙනවා, right? And now the firm thinks, okay, we can produce more wheat. තව දෙකක් වැඩි කරනවා. You increase the amount of wheat by 2 units. What would happen now? Now, when you produce, now here you gave up 2 bikes. You gave up 2 bikes. And now you produce 2 extra units of wheat. Now you give up how many? There was 12 metana, but now this is 8. So from 12 to 8, you give up 4 bikes. Now can you see? Because you take away more people from bike production. Bike production එක කරපු employees labor අරගෙන wheat වලට දානකොට now these are different. මුලින්ම ගත්ත හොඳම group එක. ඊට පස්සේ ඊට පස්සේ ටිකක් ඊට වඩා skill එක අඩු අය වෙන්න පුළුවන්. So likewise, this applies to any resource, right? So now you take away more people. Likewise, you take away more people to produce wheat. And as you produce more and more wheat, you can see you give up more and more bikes. When you produce 8 units of wheat, you cannot produce any bikes. So if you draw a line connecting these points, it's called the production possibility curve. And that shows the most efficient units of production in a firm or an economy. Right? Now you can see this graph shows a lot of the concepts that we discussed in the first day. The scarcity, right? Why do we take the same labor? අපිට ඕන මේ මෙතන 10 දෙනා නම් ඉන්නේ මේ 10 දෙනාව bikes වලට use කරලා we invited more labor from another country maybe, right? Or train more people. But we have a scarcity of labor. That's why when you produce more wheat, we use the same amount of people, so you have to give up bikes. That shows scarcity. Giving up shows trade-off. There's an opportunity cost. Then after wheat we have to reduce the amount of bikes. The income that you got from bikes, you don't get that anymore. Therefore, there's an opportunity cost. And these are the efficient points of production. A, B, C, D, E are the most efficient points of production, right? So then, can you, if I ask you, can you produce here, below this point? Now, A, B, C, D to E are the most efficient points of production. If so, if I ask you whether you can produce 4 units of bikes and 2 units of wheat, you can, but it's inefficient. Because we know when you produce 4 units of bikes, you can produce 6 units of or 7 units of wheat, right? When you produce 4 units of bikes, you can produce 7 units of wheat. But now you're producing only 2 units of wheat. හතක් හදන්න පුළුවන් වෙලාවෙදී දෙකයි හදන්න මෙතන produce කරොත්. Therefore, we call this inefficient. inefficient, meaning the resources that you have, labor or land or whatever the resources, are not fully utilized in this economy, right? So you're producing less than your potential or below your potential. How about, this is the efficient point, and how about this red line, so red dot here above the graph? So if I ask you, can you produce? You cannot, because this point is beyond the efficient point. මේකට whole firm එකට efficiently produce කරන්න පුළුවන් points ටික මේ curve එකෙන් පෙන්නලා තියෙනවා. So any point beyond that curve is good if you can produce. That's where the economy wants to be. That's where we want to push. But given the resources we have now in the country, the technology, the labor, the land, the resources, given those resources, this point is impossible to achieve. That's the theory, right? It's impossible to achieve. But that's where you want to be. As a firm or as an economy, you want to push the boundaries, isn't it? You want to push. So any economy, that's how you economic develop, by increasing your goods and service production. But given the resources we have now, we can't achieve this. But what can you do to push this curve forward? So we would want to look at the shifters of production possibility curve. The change in resources, quantity or quality. If you increase the amount of resources, quality, quantity, you can push this curve. Now, for example, you can't increase the amount of land in Australia has, but you can increase the productivity, right? The amount of output that you get from a particular area. Productivity, land productivity, labor productivity, resource productivity, you can increase. So through technology, right? Because given the technology, we can't produce more than what is given here. But if you come up with better technology, you can push this curve forward. If you skill, so given, again, labor, we might have an abundance of labor, but if they are not skilled labor, labor becomes limited, right? So by doing vocational training, skills development, introducing more technology, now you can see like all universities have technology faculties. So that's a new initiative. So likewise, you can, any country or any economy would want to increase their skilled labor, so you can push, right? So that's why education, skill development is important to push this forward so you can attain higher output. Right? Change in technology, change in trade, specialization. So like I said, that's why this graph is important. It also helps us understand why, for example, countries should specialize in certain goods and import the other goods that they have a higher opportunity cost. So, yeah. Okay, so that's the third type relationship, very briefly.
Recording stopped.
Okay, so next we will talk about the cost theory. Guys say that we have not had a proper break, so we'll take a long break, and I'll see you at 12 again, okay? Do you have any questions before we take the break? So I'll be back at 12. So like I said, so today we'll cover most of the theory, and next week we will go into more applications, and also we will talk about, sort of discuss a few questions that you might expect for the exam next week. Okay? So I'll be back at 12, and see you then. two types, explicit cost and implicit cost, right? So explicit costs are direct costs, or we say accounting costs. For example, an accountant would include these types of costs, which are direct, or we also call it money cost. And so these are the actual expenditure incurred by a firm to purchase or hire the inputs it needs in the production process. So these are the payments for the factors of production. For example, for land, you would pay rent. For labor, you would pay wages. For capital, it's interest. So, apart from that, insurance, advertising, and so on. These direct monetary costs will come under explicit costs. And the other type is implicit costs. So it's the opposite. They are not really tangible costs, but they are that has already incurred but not necessarily shown or reported as a separate expense. So this will, your accounts, financial accounts would not show this type of cost. A good example is the opportunity cost. So by now we know, so that's the difference between economic analysis. You would go a step further to identify, intangible costs that are not reported as financial costs. One is the opportunity cost, and there is we would have discussed this last week as well. So one would be the opportunity cost, where that's the cost, the benefits that are foregone. When there are two options, if you pick one option, the benefit that you forego by giving up the other option is called the opportunity cost, or simply it's the cost of the next best alternative, right? And apart from this, we can think of social costs, externalities. There are different types of costs that would come under implicit costs. Right, so the example here, now if you have a piece of land, and if you have two options, one to cultivate this land, or the other one would be to build a building. And if you go for the first option, which of cultivating or having a crop, you will have to forego this benefit. And if this benefit would have or could have earned you, let's say 10,000 per month, right? Hambenati Banang building rent out up to 10,000 Hambenati Banang. If you pick the first option, you forego this option, and this amount is your opportunity cost, right? So we discussed a few examples last week, right? So to analyze or to include cost in our analysis, for our convenience, we can divide cost into two types: as fixed cost and variable cost, right? So just have a go through the slide and see if you can understand what it means. Right, so when it comes to cost, we can talk about two types: fixed cost and variable cost. So these two terms should sort of ring a bell, because we discussed fixed resources and variable resources. So the cost derived from these resources are categorized as fixed cost and variable cost. So fixed cost, the definition is they are overhead costs or supplementary costs that does not change with the change in output. Variable cost is that cost which vary or change with the quantity of output produced. So here in this lesson, we are trying to develop a relationship between quantity and cost of production. So the quantity of output and cost of production. So in the previous lecture, when we talked about or we discussed production function, there we looked at the relationship between inputs and output, isn't it? So earlier on, when we talked about production function, we looked at output. We'll call it Q. And as a function, or simply we looked at output-input relationship. So we'll call the inputs X, any input, fertilizer on land or whatever, labor, whatever, right? So we looked at the relationship between quantity and inputs, and we saw this type of relationship. When we have quantity here and X here, we saw that it has a sigmoidal shape relationship, right? So now, so we know that if this is a relationship between X and Y, Y or Q here, X stand for, or X denotes all the inputs. So there's a cost attached to the inputs, right? There's a cost of purchasing the inputs. So now we are going to look at this relationship with the cost of inputs, or cost and quantity, right? So there are two types of costs here we are going to look at, then fixed cost and variable cost. Now, if you can remember, what are variable inputs? Variable inputs were inputs that you could change within the short run, right? We all vary during the short run. So the cost attached to those inputs like fertilizer cost, labor cost, water, seeds, these are variable inputs, and the cost attached to these inputs come under variable cost. Then the fixed cost, of course, is the cost attached to the fixed inputs, such as land or buildings or machinery, right? So that's that. And so now we are going to develop relationship between quantity or output and cost, right? Cost, right? But we know cost depends on the quantity produced, right? So we will write it as C as a function of quantity, right? Now Q here is output, C is the cost, right? So C includes both these fixed cost and variable cost, right? So now keep that in mind, and so to identify the two types of costs, we need to understand the two periods of time. Now, we discussed last in the morning also, short run is a period of time during which at least one of the firm's inputs is fixed. Short run can be dedicated, at least one input is fixed. Now, in the short run, you find both fixed costs and variable costs, right? But in the long run, all fixed costs become variable. Therefore, in the long run, you only have variable costs. Like I said, if you ask me how long is the short run, there's no one answer. It depends on the type of farm. For example, for a small scale farmer, the short run might be 5 years, right? And for a small farmer, 5 years and he can't change his land extent, he can't change his machinery because you can't afford it. So the short run for him would be 5 years. But for a medium scale or large scale farm, the short run might be even 1 year or 6 months, right? Fixed resources. So short run depends on the type of farm, characteristics of the farm. Right now, in the coming slides, we will focus on the short run costs for our convenience, right? Short run costs. Now we have to keep in mind, in the short run, you find both what? fixed costs and variable costs. Fixed costs so then are variable costs so there. Right. Now we're going to derive three types of relationships: total cost, average cost, total cost, average cost, and marginal cost. Right. So let's take the total cost first. The total cost of production is divided into two parts: fixed cost and variable cost. We discussed that. So now this is what you see here. The total cost of production equals total fixed cost plus total variable cost. Right. So this is what we discussed a little while ago. So just have a read. Right, so total fixed cost and variable cost we have identified. Right, so how would this look like if you draw a generic or typical cost function? Now, on the x-axis you find output, and cost will vary with the amount of output you produce. දෙකක් හදනවට වඩා තුනක් හදනකොට වැඩි, හතරක් හදනකොට වැඩි. අඩු වෙන්නත් පුළුවන්. We'll see how it looks like, right? What would you expect? So you would expect that for a large scale firm, as you increase the level of output, amount of output, the cost in the long run to reduce. But if you draw the output, right, we can see that the typical cost function would look like this. As output increases, the cost increases, and it takes this shape, right? Output, you start at 0, 0 output, 0 cost, increase 1, cost increases, right? So it keeps increasing as you increase the output. So TVC actually stands for total cost. Now we know the total cost equals total fixed cost. Fixed cost එකක් තියෙනවා කිව්වේ buildings, machinery වගේ vary වෙන්නේ නැති cost එක. It's fixed. It does not depend on the output. Now the fixed cost does not depend on the output, whereas the variable cost will depend on the output. Right? Variable cost එක output එක වැඩි වෙනකොට වැඩි වෙනවා. And then you have the total variable cost here. T stands for total, V is variable, C is cost, right? F stands for fixed cost. Right. So how do you think this, now this we have drawn, plotted here, this one. How would you draw this cost, total fixed cost here? We know that it does not depend on the output. So how will that look like? So that's the fixed cost, isn't it? It does not depend on the output. Output එක වැඩි කරා කියලා fixed cost එක vary වෙන්නේ නැහැ. So that's a horizontal straight line. The difference between, so the total cost is the sum of these two, total fixed cost and the total variable cost. මේ දෙක එකතු වෙන තමයි total cost එක හැදෙන්නේ. එහෙනම් මේ දෙක අතර වෙනස තමයි fixed cost එක නේ. So that's a fixed cost. Right. Right. Now that we know the total cost, and from that we can derive two other relationships. So this is the total cost, number one. The second one is from this, you can derive the average cost. Average cost, right? Now, if the total cost of the production depends on the output you produced, how would you find the average cost? Output එක මත, this is Q, and this is the total cost. How would you find the average cost? So from this, we can find the average cost. Average cost is actually the total cost divided by the level of the output, right? එකකට යන cost එක, එකක cost එක. Output එකකට එකක cost එක. Total cost divided by output, right? So total cost divided by the output. And then we can also derive something very important, another relationship. Marginal cost is, how do you calculate the marginal cost? So now we're familiar with this term marginal. It's the change in the total cost, change in the total cost over change in the quantity or the output, right? The additional cost incurred when you produce one extra unit of output. Output එකකින් වැඩි කරනකොට, මෙතන 1 2 3 කියලා එකකින් එක වැඩි කරගෙන යනකොට output එකකින් වැඩි කරනකොට කොච්චරකින් total cost එක වැඩි වෙනවද? එහෙනම් volume when 0, this was the cost. When you, let's say 10, and when you increase the output by one unit, let's say now this increased to 20. So the marginal cost would be this difference, which is 10. Right? So that's the marginal cost. Change in total cost to a change in quantity. Right? So it's actually the slope of this function. Right. So now let's try and derive this. Let's take an, if you plot these values, if you plot these values on a graph, so you have output again, just like in the previous graph, output on the x-axis, and the average cost and the marginal cost on the y-axis. Now, if you go back to this relationship, if you take average cost, the average total cost, some call it average cost or average total cost. But our total cost is made up of what? Total cost total fixed cost plus total variable cost. Total fixed cost plus total variable cost. මේ දෙකම Q වලින් divide කරන්න පුළුවන්. If you divide both these here, now this you get average fixed cost. Total fixed cost එක quantity එකෙන් බෙදලා average variable cost එක බලන්න අපි total variable cost එක Q වලින් බෙදලා. Right? So if you plot the values, you will see that the average fixed cost of the firm decreases with the output. Average variable cost. Now, this is what you would expect, isn't it? As the firm grows in scale, as you increase the output, your cost decreases with time, but we'll talk about this in one of the coming slides, and then it starts increasing. Average total cost also, it reduces or decreases with the output, and after a point it starts increasing. The marginal cost goes through the minimum points of these two curves, and it goes down initially, comes to a minimum and increases. So that's the marginal cost we calculated here. And the average cost, average fixed cost and the average variable cost also on this graph. So this is average fixed cost, average variable cost, average total cost, and the marginal cost. Okay, let's take a numerical example. Okay. Let's see if you can compute it's asking you to find the total cost, and when you find the total cost, the average variable cost, average fixed cost, average total cost, so the average cost, and the marginal cost. Right, so look at this table. Now, in the first column, you have the yield or the output. And the second column, you have the total variable cost. Third column, the total fixed cost, right? So the total cost is made up of both the variable cost and the total cost. So I'll write the equations on this side so you can do the calculations. Total cost is made up of what? Total variable cost and the total fixed cost. Then the average cost is total cost divided by y or q or whatever the yield, and that is total fixed cost plus total variable cost divided by y. Right, so this will give you the average fixed cost. Total fixed cost එක y වලින් බෙදුවම අපිට වෙන average fixed cost එක. මේක variable cost එක y වලින් බෙදුවම average variable cost එක. يعني එකක fixed cost එක සහ එකක variable cost එක. Right? එක output. Marginal cost is actually the total cost divided by, change in the total cost divided by change in y, right? Meaning the additional cost that you incur to produce 1 unit of output, isn't it? It's this one. Additional cost incurred to produce 1 extra unit of output. Right, so given that, see if you can calculate these values for at least the first 3, right? This one, and this one. So take a few minutes and see if you can do the calculations. Right. So let's go through a few calculations, the first two at least. How did you calculate the total cost? So the formula is given. So total cost is total fixed cost plus total variable cost. So total fixed cost is 75. You can see now the fixed cost is not vary with the output. Output again and again, but the fixed cost is fixed. Doesn't depend on the amount. But variable cost will change. For example, if this is the yield and total variable cost might include the cost of fertilizer, cost of labor and all that. So those are variable. Yield වැඩි වෙනකොට total fixed cost එක එන්න වැඩි වෙනවා. Okay. Sorry, total variable cost එක. Fixed cost එක fixed variable cost එක එන්න වැඩි වෙනවා yield එකත් එක්ක. So to calculate the total cost, it's total fixed cost plus variable cost. Okay, can someone give me the answer? $164, isn't it? So that's the total cost. And how would you find what's the total cost here? The second one. Okay, now how would you find the average variable cost? Variable කිව්ව ගමන් අපි average කිව්ව ගමන් අපි දන්නවා it's average is per unit per output, cost per output. Variable cost per output, you know? Variable cost per output would be 89. This one may cost එක yield එකෙන් බෙදනවා එහෙනම් එකකට යන variable cost එක 89 divided by 40. Right? And this one would be 110 over how much? Over what? 50, isn't it? Output at 50. This is 40. Right. Then the third column, average fixed cost. That's fixed cost per output. Fixed cost, එකකට යන fixed cost. So that would be 75 over 40. 75 over 50. Now here you can see that as the output increases, your fixed cost will reduce. 75 is divided by 40, then 75 divided by 50, then 75 divided by 60, 70 likewise. එකම amount එක වැඩි වෙන number එකකින් බෙදනකොට it would look like this, isn't it? මේක තමයි average fixed cost එක එන්න අඩු වෙගෙන යනවා. Then the average cost. Average cost is average variable cost plus average fixed cost. You can easily find it by dividing the total cost by y. Total cost එක අපි දැන් දන්නවා 164 for the first one. 164යි මෙතන. Total cost එක output එකෙන් බෙදනවා. Okay. Output එකෙන් බෙදනවා. So that gives me the cost per unit of output. Then the marginal cost. So marginal cost is actually the change in the total cost to a change in y. Now change in total cost is this difference. Now we won't calculate the first one. For the second one, first one it would be 0 minus 164, which is 164 minus 0. So that's, but we are not given the total cost before this, so we won't calculate for that. But for the second one, total cost again minus then. We'll calculate the third one also. So here, the total cost for this one is 205. Right. So what's the difference there? Now here, this difference is 20, isn't it? Change in total cost is 20. What about this difference? How much? So this is not 20, this is 20. I thought some of you might point it out. So this is 21. 21 and 20. So that's a change in total cost. And this difference here, yield difference is 10. Again, 10. I mean, each time it's a difference of 10. So how would you calculate the marginal cost the second instance? When the total cost is 185, the marginal cost is 21 over this difference is 10. Right? When the total cost goes up to 20 and when the yield goes up to 60, it's 20 over 10. Right? So that's the marginal cost. And if I was to calculate color, we can draw the marginal cost, which will look like this graph. Right? So I'll give you a minute to go through the calculations. If there's anything you don't understand or you want me to explain, let me know. Right. So you will get questions on this for the exam, but we will do some related questions next week. Okay. So now we've looked at the production function and the cost function. And cost function, particularly the cost function, is important in understanding a lot of economic phenomena around us. Right? For example, pricing, right? And market structures, how they price their product in order to maximize profit, can be explained using costs and revenue theories. Now, so we'll move into market structures. right? So there are different types of market structures that you would see in the world around you. So what is a market structure then? Market structure are those characteristics of the market that significantly affects the behavior and interaction of buyers and sellers. Right. So when you take a market, it could be physical, right? Like you see physical markets, or it could be virtual. However, a market involves both buyers and sellers and trading, right? So there's interaction between buyers and sellers for trading. And there are different types of markets. For example, some markets have only one buyer or only one seller, right? So there are markets with just one seller or one buyer, right? And then there are markets with several sellers and several buyers, like thousands and millions of buyers and sellers. So there's a continuum of markets, right? And all these types of markets are characterized by similar characteristics when it comes to pricing, supply, barriers to entry and exit, efficiency, and competition. I think this would be clearer if I take an example. Right, so before that, what is meant by market? So market generally means a place or geographical area where buyers and sellers meet with their goods to exchange goods and services for money. In economics, market refers to a group of buyers and sellers who involves in transaction of commodities or goods and services. Right? So we all know that there are different types of markets. And markets it can go up to so many buyers and sellers. Now, depending on the structure of the market power will also vary. Right? Market power can the ability of an individual or a group to substantially influence market price. So, not sure if you've done agricultural marketing. There you would have discussed about different types of markets, pricing strategies like cost plus pricing, marginal cost pricing, and so on. So that's why we discuss the cost theory before we discuss market structure. So on that, given that theory, we will talk about different types of market structures. But again, industry is a collection of firms, each of which supplying products that have a degree of substitutability to the same potential buyer. So what this simply means is that, now what do we mean by an industry? You can think of so many industries, isn't it? Textile industry, dairy industry, vegetable industry, paddy, food and agriculture. What do we mean by an industry? What does this word mean to you? Or what comes to your mind when I say industry? Now, usually an industry is a collection of firms which sell or which trade similar products, isn't it? Now, if you take dairy industry, products are very, very similar. Unless you do a lab test, you can't even tell the products apart. Now, let's say we have 100 in this class. All of us are in the fresh milk industry. All of our products, fresh milk, will look the same. The taste will differ, but seemingly, we all know how fresh milk looks. So it will be very, very similar. Textile industry they can textile producers main industry. So what it means is now these products are substitutable and they all sell similar products. The collection of firms which sell similar products which are substitutable. Perfectly substitutable නැතත් යම් කිසි දුරකට substitutable. Right? And you find common sellers and buyers. Paddy industry එක ගත්තත් ඔක්කොම sellers ලා paddy. හැබැයි ඒගොල්ලෝගේ brands එහෙම නැත්නම් quality will be different, but it's substitutable. නේ එකක් වෙනකොට තව එකක් use කරන්න පුළුවන්. Common sellers for buyers, common sellers line law, common buyers line law, relatively homogeneous. Means, like fresh milk, it's homogeneous. Test එකක් lab test එකකින් අරගෙන Then taste kalla ballarana, seemingly it's all the same, homogeneous. Market power will be different in different industries. Right. So have a look at these characteristics of a market. So let's go through one by one. It says existence of buyers and sellers of the commodity. In a market, you find buyers and sellers, of course. And second one, the establishment of contact between buyers and sellers. So they are there and they have to establish some sort of contact, right? Either through emails or physical contact, whatever. You establish contact, and buyers and sellers deal with the same commodity and variety, so they are homogeneous, right? And there should be a price for the commodity. Now, this price will, or how they pricing strategies will also differ with the type of market they are in. Right, so that's what we will look at in the coming slides. Right. So any market structure will be categorized by the number and size of sellers and buyers. Now, in the pramana and the size of the sellers, right? Some have one, some have many, some have so many. Likewise, different market structures have different number of buyers and sellers. And the size, market share is also different in different types of markets. So then type of product. Some markets sell very homogeneous product, some not so homogeneous, some sell, if there's only one product available in the market. There's only one producer. Conditions of entry and exit. Some are markets that easily you can enter and exit. Some markets, it's very difficult. For example, if I want to enter the vegetable market or vegetable industry, it might be relatively easy, right? If I know how to grow vegetables, if I know how to price them, if I know how to pack and transport them, then it's easy. Nobody's going to stop me. But if I want to enter, say I want to start a new railway service, right? There's no private sector, and I want to start a new railway service. And that's going to be very, very difficult. If the government says, I have to build my own rail tracks, that's going to be very impossible to enter this market. Airline industry, So certain industries, it's very difficult to enter and also exit. You can't exit that easily. You have lots of rules and responsibilities. There's some legal framework behind it, so it's not easy to exit as well. And then there's transparency of information. Now, some markets, the information is quite transparent. It's all there. Now, if I want to enter the vegetable or food processing industry, relatively easy, right? Information is transparent. But when it comes to certain industries, like let's say software design or pharmaceutical industry, there are lots of industry secrets. Information is not given to the public. So that is going to be relatively difficult to enter that type of an industry. So depending on what, based on those characteristics, economists have categorized market structures into 4 key types of structures. So there's a continuum. On one end, you have the perfectly competitive market. So if I draw like a continuum, this is the range. On one end, you have the perfectly competitive market. We call it PCM, or perfect competition, right? Perfect competition. On the other side, you find monopoly. Right. So PCM, or perfect competition. Right. So just go through the slide first. Perfect competition or perfectly competitive market, what does that mean? So the name gives you a clue that there is perfect competition among the firms or the sellers in the market. So we say that there is generally a large number of buyers and sellers, right? Hundreds or thousands of sellers and buyers in the market. Buyers and sellers sell identical products, right? There's no need for advertising. They sell identical products. And each buyer and seller can act independently. Sellers and buyers are reasonably well informed. Independent in the sense you don't have to worry about what the other person does. And reasonably well informed means the information is transparent. Anybody can freely enter and exit, right? So can you think of examples for this type of a market? So there are no real perfectly competitive markets. Perfect competitive markets are not really there in the world. But a lot of the theories in economics is based on assuming a perfectly competitive market. And, like we discussed Adam Smith's theories on the first day, so that, you can see a lot of assumptions on perfectly competitive markets. The closest that you can get to a perfectly competitive market are agricultural markets, right? For example, take the wheat market or the paddy market, vegetable, dairy, milk, because these products are very much homogeneous, right? Very, very similar. If you take the rice market or the paddy market, the products are similar. Vegetables, fruits, right? They are similar products. You see loads of buyers and sellers in this type of markets. And so they are called perfectly competitive market, perfectly competitive. So another characteristics in this type of a market is that all the sellers are price takers. Now let's take the paddy industry with lots of sellers, paddy sellers, and they are all price takers. What do we mean by that? Now, we are familiar with the equilibrium. Now, if you draw the paddy market equilibrium for this type of industry, perfectly competitive. So you have supply and demand. So this would be the equilibrium of the entire market. Now, if there are, how many of us are here in this class? 63 now. So if all 63 of us are in this market selling paddy, right? All of us together, the market and supply forces actually, the market and supply forces will determine the price. This is an ideal market, like ideal kind. This is what the market should look like, although you don't have perfect competitive market in the real world, but in agricultural markets, you would expect to behave this way. So they decide on the price that both the sellers and the buyers are happy. Price and the quantity is decided or determined by the supply and demand forces. Now, this we have discussed earlier. Now, if there are 60 of us in this market, all of us will take this price. That's why we are called price takers. May market taking the buyers law. All of them are price takers. Price takers, yeah. So therefore, they will take this price. Industry can determine kind of price. Now, if I'm a seller in this market, this would be my price. Demand quantity quantity will determine the price. Price quantity, there's a relationship price. Quantity. But here, you don't have to worry about that because the price is determined by the market, and that is the price that the individuals. This is the firm. This is the industry. The industry decide the price. Market demand, supply, demand. You can decide kind of price individual firm. So they are called price takers because they will take whatever the price determined by the industry, and their goods, the paddy, will be sold by individual firms at this price. Mama, Anita Mohammed, Selkarani may price. So they are called, therefore, we are all price takers in a perfectly competitive market, right? So if someone increases the price, right, what would happen? Now, all of us will decide to sell at P star in price. But if one of us decides to increase the price, what would happen? Because all of our products are homogeneous, we will lose out, right? Nobody would buy from us because there are so many buyers, same commodity, same quality. So nobody will buy from a person who's which is expensive. So we're going to lose out. So therefore, that price will be maintained by all of us. So this is an ideal market, but we know that this doesn't exist. But so now we are going to talk about deviations from this market, right? So that's on one extreme, you find the perfectly competitive markets. Yeah, perfectly competitive market. Right, so that's done. Now we look at the other extreme. Anit endekino monopoly. Opposite, right? Monopoly. Let's look at the characteristics of a monopoly. I'm sure you all have heard of this term monopoly. This term was very much on news in the past couple of years. Monopolies, comes to gas and so on. So what do we mean by the term monopoly? So monopoly is a market in which there is one seller for a particular product There are barriers to entry to the market, and so one seller with barriers to entry. So there are different reasons as to why there is a monopoly. For example, Sri Lanka Railway, water, tobacco. There's only one firm, isn't it? So let's see why. There are different reasons. This industry, like the airline industry or the railway industry, which the initial cost is, if it's huge and unaffordable, then they would not want to enter this market. So there could be only one as a result. For example, railway. If the government says, you can't use our railway tracks and instead you have to come up with your own, or if the cost is really, really high that the private sector cannot afford, then that becomes a natural monopoly, right? Naturally, it becomes a monopoly. So the second type is called geographic monopoly, based on absence of other sellers in certain geographical areas. So the name gives you a clue that it depends on the area. Now, for example, if a certain product can only be grown in Iceland, or if coal is only produced in, or it was only made in South Africa, then that becomes a monopoly. If something can only be grown in Norelia, that becomes a geographic monopoly. Then technological monopoly. Now, these are very common. Now, this depends on patents and copyrights. A lot of the software, pharmaceutical products, if there is a patent attached to it or copyright, and they don't want to give it to another company to produce, then that company becomes a monopoly. Okay? We see this with a lot of artwork, software, and so on. Drugs. Government monopoly. This monopoly is owned and operated by the government for reasons such as military, water, sewage, like military when it comes to social security or the economic security, or for defense reasons, security reasons, the government would not allow the private sector to run a military, right? That is solely owned by the government. Dealing arms or arms transactions will be done only by the government. Water, I'm just giving you examples. This depends from country to country, economy to economy. So water, sewage, for example, if the private sector thinks that the cost is greater than the benefits, then the private sector would not venture into this type of industry. Instead, the government, we know that it's not solely dependent on profit. They are not really profit oriented. Instead, they will move into social enterprises, or enterprises like sewage, where the cost might be greater than the benefits. Right. So for those reasons also, there might be monopolies. Right. So how will they determine their price? The next question. Now, monopoly, there's only one firm, isn't it? One firm. Can you think of any monopolies in Sri Lanka? Anyone? I've given a few.
Basmati rice shop.
Sorry, say that again, please.
Basmati rice shop.
Now that comes under paddy industry, isn't it? So paddy, of course, there's a lot, although the quality might be different, it's still not really a monopoly, isn't it? Now, if there's only one seller of that product, then that can be called as a monopoly. Right? For example, here railway, there's only one. Only the government runs the monopoly. So that can be called a monopoly. Now, even gas, if there's only one company, that can be a monopoly. If there are two, that's a duopoly. Yes, electricity and so on. Gas also, if there are two, that's a duopoly, but if there's only one, that's a monopoly. Right. So now let's see, how do they determine their price? Now for a monopoly, if there's only one, then they can price the products as they wish, right? They can increase the price as they wish. So how will this type of an industry decide or determine their price? Now we have the price. Let's have quantity here actually. Now that we have a good idea about the cost theory, let's start with the company's costs or the firm's cost. So you have cost on this side. We have price because we're going to have cost and revenue both on the same graph. So we have price and quantity. And I'm going to draw the cost curves first. So we'll start with the cost of firm. What's this cost curve called, if you can remember? This could be the total cost or the average cost, but I'm going to go with the average cost because that will help us identify the cost per unit of output. And then I'll draw what? What's this? Can someone tell me what this is? So I've just taken the average variable cost and the marginal cost. Those two curves are here. So average cost and the marginal cost. Right? So those two costs. And what else do we need to identify the pricing? Right. So we all know that any firm, except a firm that would be in a perfectly competitive market, PCMA Karen, any firm would want to maximize profit. So we say the profit maximizing condition for a firm is where their marginal revenue equals marginal cost. So this we call as a profit maximizing condition. Any firm would want to produce where marginal revenue equals marginal cost. Now revenue, we can derive this, but we're not going to do it in this class. Marginal revenue is the revenue that the additional revenue you get by selling an extra unit of your product. Marginal revenue, the additional revenue by selling an extra product, right? And the cost incurred, the marginal cost incurred for that is the marginal cost, or the additional cost incurred for that product is the marginal cost. So the profit is maximized where marginal revenue equals marginal cost. So the firm, to price its product, would want to know the marginal, the place where marginal revenue equals marginal cost, or the number of outputs where marginal revenue equals marginal cost. So before we find the price, we'll have to find the profit maximizing quantity. Output To do that, we will use this marginal revenue equals marginal cost function. Right, then and now I have the cost functions here. What else do I need to draw on this graph? Now I'm going to draw. So cost functions are okay. Now I have the marginal cost. Now I'm going to draw the revenue functions. That is going to be difficult. It's a bit crooked, but this is actually the demand curve of the firm. Right, so before that, so I didn't go into that detail, but if you go back to the cost functions, now this marginal cost curve, right? If you take the price and quantity at each of these points, right, and you draw a graph, you draw the price and the quantity on a separate graph, it would look like this. And that is the supply curve, is in price and quantity relationship depending on the curve. My supply curve. So therefore, we can show that this marginal cost curve above the average variable cost curve is actually the marginal cost, right? Sorry, the supply curve. The marginal cost above the average variable cost is the supply curve. එහෙනම් මේ marginal cost එකෙන් අපිට පෙන්නන්නේ මේ area එක තමයි firm එකේ supply curve එක. So now that is given here. We could draw that, and to identify the price, we need to know the demand-supply relationships as well. Cost function එක තියනවා මේකේ, demand-supply relationship එකක් ඕනේ, and the revenue, right? So for any firm, average revenue curve is actually the demand curve of the monopoly. Right? So don't worry too much about this. I don't want to go into detail, but this is the average revenue curve of the firm, or in other words, the demand curve of the firm. Right? We will also draw the marginal revenue because we want to identify this. Marginal revenue. Right. So now, if you take the firm, a monopoly firm, the costs are there, supply curve is there, the demand curves are there, the revenue curves are there. So how would you now identify the optimum quantity or the profit maximizing quantity and the price? Now the condition is given. If marginal revenue equals marginal cost, at that point, that would be your optimum profit maximizing quantity to produce, right? So can you identify that quantity by looking at this graph? Now, ඉස්සෙල්ලා බලනවා marginal revenue marginal cost එකට equate වෙන point එක. So marginal revenue equals marginal cost curve right there, right? So this is the amount the firm will have to produce to maximize profits, right? Q star. This is the profit maximizing quantity. Now, to find the profit and the price, what do we do? Price will be given by the demand curve. So if you draw a dotted line all the way up to the demand curve, now this will be the price at which this will be sold price. Right, now once you identify the quantity and the price, you can find the profit of the firm. So now let's do that. So to identify profit Okay. Use I or profit. Profit equals revenue minus cost, isn't it? Revenue minus cost. So let's first try to find the revenue. Revenue කියලා කියන්නේ අපිට හොයාගන්න පුළුවන් එකක මිල. Average revenue කියලා කියන්නේ එකක price is also there. So once you find the price, that's the unit price, times the quantity. P is the unit price, එකක මිල, quantity එකෙන් වැඩි කරාම අපිට ලැබෙනවා revenue. So this is the revenue of the firm, right? This box is the revenue of the firm. What about the cost? In order for us to then cost revenue එක හොයාගත්තා. So revenue එක හොයාගත්තා. Now we have to find the cost. Revenue is done. Cost. So cost, to find the cost, we will find this point, make this dotted line touches the average cost curve there. So average cost කියන්නේ එකක cost එක. Average cost times quantity would give me the cost of the firm. මේ area එක තමයි firm එකේ cost එක. Revenue එක green area එක, cost is the red area. Then what's remaining is the profit, isn't it? එහෙනම් මෙන්න මේ area එක තමයි firm එකේ profit එක වෙන්නේ. Profit, we usually write profit using I. So that's the profit of the firm. So just I'll give you some time to go through the graph and let me know if this, if you want me to expand this again. Okay. So now let's look at the other types of market structures. So now we discussed the perfectly competitive market, then the monopoly, the two extremes. And then now we look at the monopolistic competition, right? MC stands for monopolistic competition, right? So read the characteristics of this market. So monopolistic competition has a large number of firms to compete. Each firm produces differentiated products. Firms compete on product quality, price, and marketing. Firms are free to enter and exit. So monopolistic competition. So when you see the two words, you see that there is competition. At the same time, there's some variation or differentiation in the products. So in this type of a firm, there are so many sellers and buyers, but not as many as in the perfect competitive market. You find lots of substitute products in this market. Therefore, we know that if there are substitutes, it's very difficult to vary the prices because price easily they would go to another firm, another seller. Therefore, rather than having price competition, they would mainly focus on quality competition, non-price competition strategies, particularly like differentiation in quality, providing a better service, different types of marketing strategies and so on to compete, and relatively free to enter and exit lots of differentiated products because there are lots of substitutes, right? Any examples? So here I have listed a few, like, biscuits. You have lots of substitutes, jam, cordial, toothpastes. And so they basically focus on product differentiation, providing better service, and non-price, different types of non-price competition. Giveaways like buy one, get one free, offers, promotions, and so on. So again, in this type of a firm, also any firm apart from the ideal perfectly competitive market, they would price where marginal cost equals marginal revenue. So if I ask you to draw the price structure, it's very similar to this one. It's the same actually, but only the demand curve would be different. Elasticity discuss this demand curve varies when there are substitutes, right? It becomes relatively inelastic, isn't it? So therefore, the demand curve is slope have a structure. The pricing, this price structure is the same, right? Because a bit slope a bit of profit by revenue, cost, profit, you can find. So that's the monopolistic competition. Okay, there are very close substitutes. Okay, the next one is oligopoly. So oligopoly is a market in which, so now the last type of market that we are going to talk about is this one. Oligopoly. So you can see now it's a bit more closer to monopoly. So less markets. So you usually say like less than 9 markets you would see in an oligopoly. De facto it would be a duopoly. So oligopoly is very few sellers with high market share usually. So they would always try to increase their market share because there are few. You would see like certain fast food chains. Any examples in Sri Lanka? We can think of mobile or internet service providers, like few, isn't it? Less than 9 firms providing mobile service or internet service. So in an oligopoly, now these firms are they don't work independently. They're actually dependent. They would look at what the others do and do certain strategies, promotions, pricing strategies by looking at what the other firms do. For example, one firm gives, free-minute packages or something, off-peak packages. Then the other firms would also try to follow suit and do something similar. So they are price makers. Okay. Another thing is that except the perfectly competitive market in මේ end එක අපි ඉස්සලම කතා කර perfectly competitive market එක අරන්න all others මේක අරන්න all others are price makers because they can make their price or they can fix their price as they wish. Right. So another thing that you can see in this, so this type of market has pros and cons. One thing that you can see prominent is collusion, right? So firms get together and collude. One good example is OPEC, Organization of Petroleum Exporting Countries in the Middle East. They would, all petroleum exporting countries in that area has formed OPEC. And it's not only that, but if these firms collude, they can be very influential in terms of, economic impact, even politics. We know how strong OPEC is. So the governments would want to sort of minimize collusion because if they get together, then they can decide price, they can have huge economic impacts, which can even be negative. So collusion is where they get together and decide price and take certain actions as one firm, right? Collude. They take certain actions together. Even OPEC, they would not allow certain other countries who export oil to join their membership. So it's a very strong collusion. Price fixing can also be done, like I said, in a collusion. And another thing that you would see in this type of a market is this demand curve here. This demand curve is a straight line, isn't it, in other types of markets? But here, if we draw the demand curve, I mean, we can draw the cost curves and all that, very similar to the one we did with monopoly. So we have price and quantity. But the demand curve here, we say, is kinked slightly. Now, instead of it going this way as a straight line, it sort of shifts this way. And it's kinked because so that can have implications. If this is the market price, if one increases the price, right, and if the others don't increase the price, they are going to lose a lot. And at the same time, if one decreases the price and the others don't, again, they are going to lose their profit, right? So therefore, these firms will look at how the others perform, what strategies they follow, and they also try to follow something, a similar strategy. Right, so here you have sort of, so now these are price setters or price makers. Therefore, they can price wherever they want, as they wish, depending on the industry they are in. So that could even go up to certain, you would have heard of price discrimination, for example. In the case of monopoly, they can discriminate price. For example, they can sell a particular product cheaper in the local market and more expensive in another market elsewhere. Or they can have two different prices. For example, if you take railway, now the peak prices or even internet service providers do this. The peak charges are higher, off-peak charges are lower, but they give the same product, right? Or they can charge different prices from different groups of people, like one price for the same product. Let's take movie tickets. They could charge a higher price a lower price for students and senior citizens and a higher price for the others. So likewise, you can discriminate prices as well. So you can show that using illustrations on how that happens. But anyway, now this is what we discussed in a nutshell. Right. Any questions on what we have covered so far?
Recording stopped.
Right. Again, so the slides are on LMS. Sorry. I'm so sorry. I can't. Not clear. Can you say that again, Shahari, or can you send me a message in the chat box? Shahari, you want to say that again?
Of comparative. Isn't there type of
Yes.
competitive market?
These are all competitive markets, what we discussed, except for the perfectly competitive market. They are all competitive except for monopoly, because there's only one. All the rest are competitive markets. Now, when you take the perfectly competitive market, there's ideal perfect competition. Then monopoly, the duopoly, oligopoly, and monopolistic competition. Those markets have varying levels of competition. And also, that also will determine the power. For example, the monopoly has the highest market power, right? They can do whatever they want, price wherever they want. Whereas the perfectly competitive market has the lowest level of market power, right? Because they are price takers, isn't it? They can't decide the price and the quantities. Instead, they'll have to take the price that's determined by the industry. Right? So except for monopoly, the rest are all competitive markets. Is that clear?
Thank you, ma'am.
Okay. Yeah, so go through the slides, and if there's anything before we start the next lesson, we can discuss. So I think we can call it a day today, and I'll see you next week. Okay. Right, so thank you for joining, and see you same time next Saturday.